G'day, it's John here. This video is about making about engraving a work rest for a Radius Master grinder sander. It's the first time I've done a voiceover, so please excuse any ums and ahs. The laser is owned by Stuart Tankard, and here it is set up in the kitchen of his house, along with some other gear. How interesting is that for a kitchen appliance? The machine is a 30-watt fibre laser. Now, I don't pretend to know much about lasers, but I gather that the wavelength of this laser means that it will engrave metal, and with multiple passes will actually cut steel, copper, brass and so on. The laser is generated in the box behind the laptop computer, and it's transmitted by fibre optic cable to this small box with the warning sign on it, and CNC directed mirrors actually direct the laser beam to the workpiece. Only the mirrors move. The workpiece stays still. This is an example of metal cutting with that 30-watt laser. That's hacksaw blade, high-speed steel, 1.2 millimeters thick, and Stuart cut out these tiny parts which are pawls for a gear oil pump. Each of those pawls took 200 laser passes to cut it, and each one took about 2 minutes to finish. No other finishing was required. Stuart uses a steel plate to protect the aluminium base plate of the laser machine. The lines on that sacrificial plate are the ones that he used to make my base plate, or make the work rest for my acute tool sharpening system grinder. Those lines are only 10 to 20 microns thick. The design for today's workpiece was CAD drawn and saved as a DXF, which is then imported into the laser program, which is shown now. So here's the laser in action. One complete pass of today's design took 1.5 minutes, and 2 passes were required to get a good depth. The red dot is just a visible light marker. The laser wavelength is invisible to the human eye, although it would severely damage it if it got reflected into it. The order of the engraving is the same as the order in which it was drawn. The brown colour is, I presume, iron oxide dust. It does accumulate in the grooves that it cuts, and I imagine that it slows down or reduces the depth of each subsequent pass of the laser. So maybe some kind of a blower system to get rid of the dust as it's being cut would help. And where the screw holes are located, look how the laser has cut down the slopes of the screw hole and into the base plate underneath. I imagine those marks are slightly wider than the ones on the surface because the focusing wouldn't be as good down deeper. And here's Stuart wiping off that iron oxide dust. Later I polished the plate with fine emery paper, and in a moment you'll see a close-up of just how sharp these lines are. The laser itself is 0.01 of a millimetre wide, and I guess that narrowness of the cutting beam is the reason that those lines are so fine. And you can see those lines in the screw hole too. I'm quite sure that no mechanical engraving system would get lines which are as fine or as regular as this. Very impressive. This is a broach guide which I was borrowing from Stuart. So as a final demonstration, he engraved its size on the top, and as you can see, it's incredibly regular and neat. It was quick. The whole thing took less than a minute. And I'm quite sure that this is better than stamping or any handheld engraver, and this will become the method of choice for